All right, chapter 15 covers the inference for regression, so I'm going to go through just some straight up inference. So when you are running a hypothesis test for regression, most of the time it's going to be that you're testing the hypothesis of if there's a linear relationship, and it's another t-test, just FYI. So it's really a kind of what you're going to be looking at is your slope, to see if there's some sort of linear relationship. So your hypothesis, your null hypothesis statement, note down here, is beta equals 0, which would imply that, well, if you think about if beta is 0, beta is your parameter notation for slope. So if you're thinking your slope is 0, that implies you don't have a linear relationship, because beta equals 0, of course, is just a horizontal line. Okay, so I'm going to write that in there, just some facts. So a slope of 0 is a horizontal line, and based off that, you know that there wouldn't be a linear relationship. So the null hypothesis states that there is no linear relationship, obviously between x and y. Or you could say there's no correlation. That might be a question that you're asked, between x and y. You also could say the least squared regression line is not a good predictor of y based on x. So any of those are appropriate, maybe with the exception of the first bullet. So you might say there's no linear relationship, or there's no correlation, or that regression line is not a good predictor. Really all saying the same thing in a nutshell. Your alternative then, just what you've known, you might have a two-sided not equal to, left-tailed less than, or right-tailed greater than. And what that's saying in words, of course, if beta doesn't equal 0, you're saying that the x-coordinate does have an effect on the y-coordinate, or there is some correlation, or there is a linear relationship. If beta is less than 0, if your alternative, then you're thinking that the x has a negative effect on y, or that you have a negative correlation, or you have a negative linear relationship. And of course, if it's greater than 0, x has a positive effect on y, so you have a positive correlation, or you have a positive linear relationship. Your conditions for an inference test, I talked about in the first video, so you can go back and watch that, but I'll remind you that your conditions are to check that the responses are independent, and that's just something that you, well, for the most part, assume. Your scatter plot should show a straight line relationship between x and y, and the standard deviation of y is the same for all of the x values. And I'll remind you that for these two, you will look at the residual plot, which again I talked about in the first video. And if that residual plot shows a random scatter and there's not a lot of spread, then both of those checks should be met. And then the last one, your response varies normally about the regression line. And that one, you're going to do some sort of a univariate plot on your residuals. So like a box plot or a histogram, just to see if that appears to be normal. So it's a lot of work. That's probably the hardest part about the whole inference procedure. So kind of think in the phantoms, right? You're stating the hypotheses, you're checking your conditions. Step 3 is your calculation, which actually is a quite simple calculation. Your test statistic is your statistic minus your parameter. Well, if you think about B is your statistic notation for slope minus beta, which would be your parameter notation. But if you remember, the null hypothesis claims that beta equals 0. Hence, you don't have that, right? So that's why it's basically just little b. However, FYI, if this null hypothesis claims that beta is 1 or 5 or negative 7, something other than 1, then you're going to have a minus beta. Now, most of the time, especially in your textbook, that doesn't happen. So just something to ponder on. Another thing to note, your degrees of freedom is n minus 2 and not n minus 1, so that's something that's different. And then SE sub b is the standard error of your slope, and that will be something that's usually given to you. Then, of course, step 4 is interpretation. So is your p-value small, you would reject the null, and there is a linear relationship, or is your p-value large, you fail to reject, and there is no linear relationship. So let's try to put this together. So this problem here, this example problem says, a study of the force in pounds required to draw a plow at tractor speed X in miles per hour gave the following data. Okay, so you can see that. And pause the video, take a second, put that data into your calculator. So maybe the force in, or the speed in list 1 and the force in list 2 or something. Then you get all this output here also. So you have, here's the regression output from Minitab. So that's kind of nice. They give you some stuff. So let's just make sure you can identify what all this information is telling you. So first it says residual standard error is 19.1, and I want you to remember that that's S, the error or the standard deviation of your residuals. Multiple R squared, you don't need to know that. N equals 10 just tells you have 10 data points. The F statistic you won't have to know. So down here you have your intercept and the coefficient of that, so that's your y-intercept. Then you have x and the coefficient of that, so there's your slope. So I'm just going to jot down my prediction equation actually, since I know that. And I'm just going to round here to squeeze it in. Then you notice you have your standard errors for your y-intercept and you have your standard error for your slope. So here is my standard error for slope, which I'm going to need. Then note you have your test statistic for your y-intercept and your slope, and you also have your p-value for your y-intercept and your slope. So you want to, I guess I didn't pose a question, sorry. So your question would be to follow phantoms to determine if speed is useful in predicting force. All right, so if it's useful in predicting, then there should be some sort of linear relationship. So my first step is to write my hypotheses, which might state beta equals 0, and that's implying that speed is useful, is not useful, because there's no slope, in predicting force. Or there's no correlation, or there's no linear relationship. My alternative then, it just says if it's useful, so I'm going to do a two-tailed because it didn't say anything about if you thought it was going to be a positive or a negative relationship, just if there's a relationship. So in other words, speed is useful in predicting force, or there is a linear relationship that can be used in predicting force. So that's your first step. Then your second step is to check your conditions. So I'm going to, here's where it would be, unfortunately, you have to type all that data in your calculator. So again, pause the video and do that because I'm going to move this slide over so you can't see the data anymore. So take a second and put that data in your calculator if you want to follow along. And when I put that in my calculator, so I'm on step 2, kind of doing my assumptions. And I'm going to take a look at the original scatter plot, and you don't really have to get caught up on labels and whatnot, but it definitely shows a linear relationship. Okay, so just kind of looking at that pattern, it looks linear. Then you should look, so this is my original scatter plot. I will label that. Then you should look at your residual plot and draw that, and that should show a random scatter. So my residual plot just backs up that I have a linear relationship. And it also shows me I have pretty equal spread throughout. So the standard deviation of y is the same for all x's. Okay, so I checked that, I checked that, I checked that. And then I can assume that my response variable is independent. And those are your 3 assumptions. All right, so then step 3 is to find the test statistics. I'm going to scooch this up, and your test statistic is b minus the standard error for slope, so slope minus the standard error. And I guess if you go back in this video, if you rewind, you can look at the output, but anyway, it gave you the slope. and that was 53.3143, and it also gave you the standard error for slope, which was 3.6270. So my test statistic is 14.6993, and your p-value, if you do t-CDF from your test statistic to infinity and your degrees of freedom, is your data points minus 2, so that's going to be 8 because I had 10 data points. So that's all the information you need. Then I need to double this because I had a two-tailed alternative, and my p-value equals 0.000003, so very small. On your calculator, 84s, if you go to Stat and go to all your test menus, you have what's called a linear regression t-test. You can put all this information in your calculator and get all this, the test statistic, the p-value, without doing this work also. Please show your test statistic calculation, however, or at least this. 89s, if you go to your test menu, which is F6, you also have the linear regression t-test, and it's very straightforward. So then finally I can state my conclusion. So because my p-value is very small, is small, very small, less than any significant level, right, there is evidence, sufficient evidence, strong evidence, that the least squared regression line is useful for predicting force based on tractor speed. Or there does appear to be a linear relationship, or there does appear to be correlation. And obviously because of this, I could conclude probably that there's a positive linear relationship simply because my slope was positive. However, they didn't ask that of you.